Hello and welcome to How To Maths. My name is Sophia and I'm joined by Isabel. Today we're going to be talking about place value.
Place value is the idea that our whole number system works on. You see, where you put a digit changes its value.
To really understand how it all works, we need to take a little trip back in history.
Bob, I'm so glad I found you. There's a wolf on the loose and it's eating people's sheep. Have you still got all of yours?
I think so.
Well, how many do you have?
Lots.
How much is lots?
It's more than a few, but less than loads.
So, heaps.
No, it's more like stacks.
Look, just write down how many sheep you have and then we can go and check they're all still there.
Okay.
One eternity later.
Right. This is how many sheep I have.
Wow, you were right. That is lots. Now, let's go and check if they're all still there. They've all been eaten.
Took me so long to write down this number. My sheep have all been eaten by the wolf.
That's really bad. Sorry, too soon?
So as you can see, early systems for recording numbers took a long time to record, with one symbol representing one thing.
That would mean if you wanted to write the number 300, you have to write 300 symbols.
As time progressed, civilizations such as the Greeks, Egyptians, and Romans developed systems where a symbol could represent more than one thing.
For example, the Romans used V to represent 5, X for 10, L for 50, C for 100, and so on.
These systems were still a little bit too difficult because you had to add up all the symbols to figure out how many you had.
By then, a new system emerged from India that used something called positional notation.
This meant that where a symbol appeared changes its value. This was really clever because it meant you didn't need to use lots of different symbols to represent different amounts. You could reuse just a few and put them in different places.
These clever mathematicians used only 10 symbols, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 0.
With just these 10 symbols you could write any number imaginable.
I wonder why they settled on 10 symbols.
Every number is divided into columns or places. Each of these represents a group 10 times bigger than the last one.
For example, this first column is where ones go. This is where single things go, like one sheep or one apple. We could use these blocks to represent ones.
Let's say you had 7 apples. How would you represent that?
I would put that in the ones column, like this.
What if you had another 7 ones? How would you write that?
Okay, so think back to our symbols. What was the symbol for 14?
There wasn't one. It went from 0 to 9.
That's right, but this is where our columns come in. When a column has 10 in it, we group them together and move them to the next column.
So because we can't have 14 ones in the ones column, we could group these 10 ones together into one 10.
We would then put them in the tens column.
And to write that number, you would record how many of each thing is in each column. So, for this number, we would have 110, so we would write the symbol for 1 in the tens column, and for 4 ones, so we would write the symbol for 4 in the ones columns.
The same idea applies over and over again. Once you have 10, you group them together and move them up a column. For example, 10 tens make 100, so the next column up is for hundreds. 10 hundreds make 1,000, so the next column is for thousands, and so on.
Time for some questions. Time for questions. Can you work out how many ones, tens, hundreds and thousands are in this number? That's right, it was 3 ones, 4 tens, 600s and 2000s. Well done.
Now, have you noticed that every time we go up a column, our groups get 10 times bigger, and every time we go down a column, the groups get 10 times smaller?
But what happens when we get to ones? What is 10 times smaller than 1?
Good question. That is where decimals comes in. Remember, 10 of one column makes 1 of the next. Well, if you think about that the other way round, 1 of this column makes 10 of this one.
But what is 10 times smaller than 1?
A tenth. Think about it this way. If you had one apple and cut it into 10 equally sized pieces, each of those pieces would be called a tenth.
Because 10 of them would make a whole one.
That's right. So the column we use for the tens is this one, the column before the ones. Also, to show that all the columns from here down represent less than 1, we use a dot called a decimal point.
So after the tenths would be the hundreds?
That's right, because if you took one of the tenths, cut it into 10 pieces, it would be called a hundredth. Because you need 100 of them to make a whole one.
Time for some questions. Ooh, it's question time. Ooh. Now it's time for some decimals. Can you tell me how many tens, ones, tenths, and hundredths are in this question? Answer time. There were 2 tens, 3 ones, 4 tenths, 5 hundredths. So, well done if you got that right. Cheese!
Let's have a quick recap of what we have talked about today.
Our number system relies on place value. We have columns that represent different groups. Whichever digit is in that column shows how many of those groups we have. 10 of one group makes 1 of the next. 10 ones make 10, 10 tens make 100, and 10 hundreds make 1,000. We also have columns for smaller than 1, such as tenths and hundredths.
Hopefully you found this video useful. If you have, give it a like and check out some of our other videos.
And whilst you're there, why not subscribe to our channel and click the bell icon to receive notifications when we release new videos.
See you soon.
Bye!